Yeah, looks good.
Great. Great. Well, thanks. Thanks, Ken. And thanks, everyone, for coming to today's session on involving students in applied research. My name is Rob Nickel. I'm the manager of the Bioindustrial Process Research Center here in Sarnia, Ontario. Today, I will just give a few brief slides. I believe Mike has some as well. Mine, I will have a small bit of content just on who we are, how we hire those students, and what are the benefits of hiring those students, for both parties. And very much looking forward to chatting afterwards and having a nice discussion on this topic. So who we are, part of the who we are, this is one of our groups. I say one of because they change quite often. We hire a lot of students each year. This picture right here shows about half of these people are permanent research scientists and half of them are students. So this is the core of the Bioindustrial Process Research Center. The B stands for bio. So some of the things we do are, or all of the things we do are bio-related, even sometimes chemically related chemical analysis. So a great group, very busy, very competent, but those students, as we'll talk about, maybe during the Q&A, quite cycle through our center quite a lot and really keep us on our toes, hiring all those students and making sure they're on track. So those students, who are they and where do we find them? Well, that's probably on the next slide. Right now, I will talk about just our raw numbers on the BPR side of things. So number of students involved and then the student number of hours shown on this slide. So as I mentioned, we hire a lot of students every year. We have expected versus actual in terms of our KPI. So in this slide, you can see our previous years. So we're hiring about 50 to 60 currently students a year. That's our target. And for halfway through 2021, we're about halfway through that target, maybe a little more. So we're on track. There's a bit of a discrepancy for how many hours we have those students working. That's just a outcome of number of student contracts. We found it's far more preferable and more efficient to hire students for longer contracts. So we hire them for 8 months, 12 months, hopefully, and then their hours go up. So reduced number of contracts remains reduced numbers of students, for KPIs as we're counting, but they work for us out for a longer amount of time. BPRC, as I said, is anything bio-related. We have a lot of great equipment. It's over 5 million in equipment from CFI and the Ontario portion of that as well, thanks to our funders. A lot of great fermentation equipment that's shown here. That's a large 40-liter bioreactor with all the bells and whistles. We can measure what's going out, measure what's coming out in real time. We have a lot of great analytical equipment, but didn't include a picture of that because it's a bit, boring, gray boxes on a bench, but really great equipment. And if anyone's ever interested in the Sarnia area, I'd be very happy to show you around, show you our facilities and show you our capable personnel as well. So back to the student side of things, we have this Power PI program that is useful for tracking, counting KPIs. So we use this to really take a deep dive into where we are, where we're going, are we on track? So Lambton College has two TACs, the BPRC TAC that I'm the manager of and LMIC, which is the manufacturing TAC. So I've here just taken a quick snapshot of some of these student characteristics. Again, this is just a snapshot. These numbers change continuously. We have different research groups at Lambton. We have an energy group and other groups as well. So we could have a very in-depth comparison, but just comparing the two TACs, we can take quick snapshots and look at who these students are. So in terms of citizenship, we'll see that the BPRC has about 36% of our complement is international, and the rest remaining are Canadian citizens. LMIC, that manufacturing side, has a very large number, a higher amount of international students and permanent residents, and quite a small, relatively speaking, amount of Canadian citizens. If we look at the gender on this side, BPRC has quite a good complement of women researchers, LMIC not that much. So this is a great little snapshot. We can then, as a group, internally start to tease apart, why are these things this way, and how do we improve on certain aspects we want to improve on. So that's a little snapshot of the students that we hire, where they're from, and then how do we pay for them, the funding aspect. So here again is BPRC TAC on this side and LMIC TAC on this side. And I know it's a bit tough to read these. This is just raw data right from our Power PI database. Just wanted to show you what it would look like. So it can be a bit tough to read all these little percentages, but the idea I'm trying to convey here is it's quite diverse. And again, there's differences between our two TACs, and then we could dive into why are there differences. But for the BPR side of things, mainly we hire co-op students, we hire research students, and we hire grad students, which is this last bar. By graduate students, we mean a graduate of a college program or a university program, not a university grad student, a master's or PhD, although we do hire those type of researchers as well. So just BPRC versus LMIC, quite a diverse amount of funding, how we pay for the students, and also a bit different between the two groups. And that's just the nature of our two areas of expertise. So for BPRC, there are things that are a bit unique to us, like OMAFRA, doing a lot of agriculture and food research. So the LMIC, the manufacturing side, isn't doing that much of it. But then there's some commonalities. We both have NSERC engages. We both have NSERC TAC. We both have Lambton College internal funds just to support some of these students. Some of the students are unpaid volunteers, but this slide shows of those ones that are paid, how do we pay them? We could even in the Power PI database break it down further. Those research students could be permanent versus, not permanent, full-time versus part-time or temporary. So it's quite powerful software, and it really gives us a nice look about where we are and where we're going. So we hire a lot of students. What are the benefits to those students? Shown in this flow chart. So research and innovation department is working with the other side, technically the faculty side and those students. We come together to work on hopefully interesting research projects that gives the student real world experience. They can take that experience back to class. So it helps them in the classroom, but it also helps the student at the end become a better qualified student, better connections to industry, right? One day when they're graduated from here, they're going to go on and hopefully get an interesting job. So it helps them, it helps professors in the classroom have the latest and greatest info and trends in industry. So it helps the students, helps the faculty. It also helps us, the research and innovation side. We can really work together to make those connections with students. Those students can even show us things and point us in new and interesting directions. So it's very, very synergistic, very complementary system of working together. Other benefits for the students, they get experiential learning and work integrated learning. Some of our students do work right on a site at a facility, right integrated within a work spot. They get advanced skills. I mentioned all that great equipment we have. So they get great training on very expensive equipment, HPLCs, GCs, GCMS, and then a lot of interesting botanical extraction equipment. Supercritical carbon dioxide extraction is a big thing now, especially for cannabis manufacturers. We have one of those. So the students really get what they need in terms of equipment time and really learning new skills on very expensive, fine equipment. That makes them more competitive when they're out there looking for jobs. They have those networking opportunities. Once they leave us, they often will go work for that company that they worked on for that project while they were at Lambton. And then financial gain. So of course, other than the unpaid volunteers, we do pay them, and we pay them quite well, a bit above minimum wage, somewhere between $16 and $20 an hour. Then those students also get a whole bunch of other skills too that you might not directly think of in terms of a bioanalytical lab, proposal development, project planning, talking and translating results to the company partner, and then soft skills, working on a team and getting things done on time and all those sorts of great things. So great relationship. We're happy to hire so many students. It's great for us. It's great for the students. So we're quite pleased with that. And hopefully we have some interesting tips and ideas for you in keeping those students engaged and active in those research projects. So thanks very much, everyone. That's it for me and my few brief slides. Looking forward to the discussion. Thanks a lot. Going to try to stop sharing. There we go.
Thanks, Rob. So I'll share my screen. I'll get started on mine, and then we can obviously turn it over to discussion. Okay, so thanks for joining us this afternoon. My name is Mike Comito. I'm the Director of Applied Research and Innovation at Cambrian College, where we have the Center for Smart Mining, which is managed by Steve Gravel, my colleague who's also on the line. So shout out to Steve and the team for all the work they're doing. Cambrian established its first TAC in 2019. So, admittedly, Steve and the crew here have been working through the challenges, I think, of getting a TAC off the ground in the middle of a pandemic, more or less. We've been operating more so remotely than we have on campus, although I am broadcasting to you live from Cambrian today. So what I wanted to talk to you about today is some of the best practices that we've, recently, I think, started to implement, with the Center for Smart Mining, but also I think more broadly as some practices we're doing in applied research. Certainly, I think that what I'm going to tell you is not necessarily revolutionary or groundbreaking, but I do think that that's the benefit of these best practices workshops that Tech Access puts on, is that you get to hear some of these things that you may not have thought about, or maybe you do that and you take it for granted, and maybe somebody else has thought about it for the first time now. And so that's kind of what I wanted to touch on today. And so the first example I wanted to kind of showcase here is that when we launched the Center for Smart Mining in 2019, we eventually launched a brand last year where you could see the logo for the Center for Smart Mining is featured in that photograph. And as part of the brand package that was done by the graphic designer we hired, who was actually a former professor in the graphic design program at Cambrian, one of the mock-ups he had was to have the center's logo and branding put onto a wall. And ideally for us, this is the first wall that you see when you come into the Glencore Center for Innovation, which is where Applied Research headquarters are at Cambrian. And so we thought it would be great to not only display the Center for Smart Mining logo there, but to use our equipment to produce it. We obviously could have done a mural or painted it on, but we thought, given that we're here in Sudbury, the majority of our clients that we service are in the mining or heavy industries, we want to do something that kind of showcases our capacity that we have here in Sudbury. So we cut all of these letters out of aluminum plate, but the students did all of that work. So we have a water jet cutter, which cuts at 55,000 PSI using water and sand, basically. So it can cut through, obviously, aluminum, steel, wood, any kind of material. It can probably cut through it. And so what we had the students do is, over the course of their time in applied research, this is an example, I think, of what Rob was talking about as well, is that they get trained on specialized equipment like this. We don't have a water jet cutter in our welding and fabrication shop. So by working in applied research, the students get to interact and get hands-on experience with equipment that they otherwise wouldn't get in their program. So now when they go and graduate, they've had experience with the water jet cutter. So they were the ones that cut out all these letters. They polished them, they buffed them so they're nice and shiny. We worked with a local partner to get them installed on the wall. But again, this is an example of, I think, a homegrown solution where it was designed by a former Cambrian professor. It was then created by Cambrian students. And it now kind of identifies, when you walk into this facility, you're in the right place if you're looking for the Center for Smart Mining. And so this is just one example, but I think this example is worth highlighting because this is not obviously a project activity. We have these students, Darby and Sam. Sam is on the left and Darby is on the right. Catherine is the furthest on your right. She's currently not working with us anymore, but we still have Sam and Darby working for us. But the interesting thing about that is that we have Sam and Darby working for us on projects. So they're being paid for by project activity budgets. But over the summer, we actually hired them full-time through Cambrian's on-campus work study program. And I'm sure those of you on the call have similar programs set up at your college. We call it TFE here at Cambrian, but this is basically a work study program. Typically, you would see it deployed when students are hired to do housekeeping activities over the summer, whether it's painting the residence buildings or working in facilities management. What we thought, now that we've reached a critical point, I think, in our development, that having students hired full-time outside of project funds is beneficial for us because it allows us to invest time on things like training them on the water jet cutter, having them cut out lettering for our logo and our branding. Because otherwise, if we're working on a project with a partner, it would be unfair to that partner to have us spend 50 hours teaching and training the students how to use the water jet cutter, or have that partner pay for hours that were spent buffing and polishing letters that are not part of their project outcomes. And so for us, this was a model that I think we're now going to begin to look at full time in the summer. Sam and Darby are they're no longer on the work study program because school's in full swing again, and so they're not able to work full-time hours for us, but they are still working part-time for us on specific project budgets. And so that's where they're being paid for right now. But it really gave us that additional capacity to spend more time with them in the summer. I think it also gives us, I think, a little bit more flexibility, frees up some of the time for our techs and our research staff, because in between project activities or other assignments we can put them on, they've been a great asset to have in our shops in terms of shop management, shop organization, cleanup, things like that, where again, not having to rely exclusively on project budgets, we're able to kind of deploy them how we see fit and hopefully provide them with an experiential learning opportunity, even if it's not necessarily tied to a project. And so I think Sam and Darby would both attest to having that summer with us has really kind of set them up for getting back into second year of the program. So they're in a 2-year program. So we hired them initially. We hired Darby first towards the end of last year. So she was just coming to the end of her first year in the welding and fab program. And then we hired her as a full-time summer student along with Sam. Catherine came around towards the end of the summer and continued on to work with us until she found a different job outside of campus in September. But that raises another interesting point that obviously we've invested a lot of time and energy to cultivate those skills with Sam and Darby, but they're going to graduate in the spring, leaving us without, welding and fabrication students, which, as much as the Center for Smart Mining obviously focuses on facilitating technology adoption for mining companies, and so there's obviously a high tech focus to it, it's still a heavy industry. So we're always going to need, welding and fabrication to build and engineer a lot of these solutions. And so for us in the shops that we have here, welding and fabrication is key to a lot of our project activities. So obviously this leads to succession planning. And again, if this reference doesn't land, what are you doing? You should be watching Succession on Sundays. So we've realized that when Sam and Darby graduate, there'll be a bit of a vacuum when it comes to our capacity on the student side. We still have a technician who works for us, and he's skilled in fabrication. And we also have a mechanical engineer who kind of works hand in glove with the technician and the students. But obviously, once they graduate, that'll be a bit of a blow for us. So what we've recently done is we've now onboarded 2 first-year welding and fabrication students to work with Sam and Darby. So these 2 students have started about 3 weeks ago. They're not obviously on-campus work students. They're being paid through project activities. But what this will allow us to do is, I think, to have that succession plan in place so that when Sam and Darby graduate, these next 2 students will become our second years next year. They will then train the next group of first years. And then as we build capacity, perhaps hiring other technicians and engineers, that will allow us to bring in maybe more than 2. I think 2 right now is the sweet spot for us, just based on the size of our shop and our shop activities. But again, I think this is something where we've always talked about succession planning, but I think having the TFEs and being able to invest in those work summer students really, I think, prepared us to do this now, because we now have 2 second-year students who I think are a cut above a lot of their peers because of the additional training and mentoring they had over the summer, that they're in a good position to work with the engineer and work with our technician to train this next group of first years. And then hopefully that process will repeat itself. So again, I think what I would leave you with is looking at those alternative sources of funding outside of the IEs and the TAC grants and MyTax, that you can bring on those students in applied research using work study programs. And then again, keeping in mind, what is your plan for the next group of students that come after that? So I think that's where I'll leave it, and looking forward to any questions that we may have from the group.
It's fantastic. Thank you both. Yeah, the session is just sort of an open discussion. Everybody feel free to ask a question, get a dialogue, share some of the best practice of your institution, what works, what doesn't. I've got 2 maybe just to jump off with. I don't know, I'm gonna do this one first. So it seems like a lot of the funding sources to enable students to get involved in applied research to offset the cost almost are trending towards a race to the bottom, where they're being pitched as just free money. Please take these kids, stick them somewhere, we'll give you money for it. I don't like that. And I wonder if there's a way that we can frame it of the prestige needed to join the team and work in attack, and they really frame it differently than how just general internship programs seem to be framed. And maybe related to that, is there a mechanism to screen for students? Are there certain competencies or skills that you want? Because I mean, once you bring on somebody and they turn out to be a dud, you're sort of stuck with them for the 4, 6, 8 month term, right? So well, what have you seen?
Mike, I saw you nodding your head. Did you have some ideas on that first part?
Yeah, I was going to say, Ken, that I think, and this is probably common at a lot of colleges across Canada, that typically the students that we get involved in applied research projects are the cream of the crop. And that's obviously not an accident. Oftentimes, we have been trying to avoid this practice because there's obviously some inherent pitfalls with it, but they are oftentimes handpicked or recommended by the faculty in their programs. Obviously, that doesn't necessarily lead us to other candidates who may not be, identified by that faculty member. And so we still also do interviews. We have posted jobs in the past, but typically it's the students who are hungry to take on additional responsibilities and learn more and work with industry partners on real world problems that you're going to get not volunteering, but applying to work within these programs. Right. And so I think that that's been a hallmark, and something that I didn't say in the presentation is that, again, Darby and Sam and Catherine and all of the students we've had, again, they come to us for a reason, and they're incredible assets for our team. And so I think there is definitely, with other potentially other programs, I think, applied research definitely has the benefit that we typically attract, I think, the high caliber students, because they want to enhance those skills. They want to have that leg up when they go out into the workforce. And so I think some of the things that we do, obviously with the work study program, any job that's posted, whether it's an applied research or housekeeping, for example, those jobs have to get posted and students can bid on them. But like I said, this is a process that we often do informally. I think the challenge that we run into is that our industry partners like to move at the speed of business, and sometimes posting a job, going through an interview process delays the start of that project. So we've tried to come up with ways where we can do more of maybe an informal interview where they come to the shop and our engineer and our technician can kind of talk to them to find out, would they be a good fit? And then that way we have a little bit of screening in place before we bring them on. I think certainly we have the flexibility within our projects because they're not necessarily when we're offering applied research project opportunities, we're not necessarily offering them a full term to say, we're going to hire you on for the next 6 to 8 months. We're going to hire you on for, up to 20 hours a week for as long as, the project activities require you. Right. So I think in the past, we've had students who have come on, they didn't work out, they were removed from the project. We onboarded new students, but certainly there are some challenges there if you're not able to have that screening process. You may find out quickly that maybe they're not a good fit for the program.
Thanks. And I guess I'll just tack on a little bit. And speaking of tacking on, every tack is different. So at Lambton, we're lucky in a sense that we're so busy. We have so many projects. We have a great need for students, and not just so many projects, so many diverse projects. So if that student isn't working out on a growing plants fertilizer project, maybe they could go work on biomaterials or analytical chemistry or all sorts of things. I'd also like to echo what Mike said. We really go for the cream of the crop, and so far we've been quite lucky. So I think in our particular case, we don't really have those issues, but I can see there could be an issue, with a funding package where the amount of funding might get ahead of the projects, right? And you have a large amount of money and not as many projects yet to do, and you hire a bunch of students now, and then it becomes an exercise in keeping them busy. I wouldn't recommend that. And I guess that's my recommendation, to kind of avoid those situations. But we haven't personally faced that problem really at Lambton too much.
Awesome. I see Sean, get your hand up.
Yeah, thanks guys. I guess kind of a question, kind of an observation. It was interesting to note the relatively lower number of unpaid student volunteers, which is interesting. I guess in our attack here, I would say the majority of our student involvement that we track would be unpaid, either volunteer or just experienced work. I think that's just a function of there's a lot of interest, maybe in overlap with the courses offered at Olds College versus compared to what we do here, and only having so many paid opportunities for students to be involved, whether it's interns or summer students. So I guess the question would be, and Robbie kind of mentioned it, what proportion, or how would that break down in terms of your proportion of unpaid student volunteers? And then after that, I'll kind of mention another program we have here that kind of promotes that, but I'll let you guys answer first.
Sure. And unfortunately, I don't know our exact number of unpaid. I think that earlier slide I showed about 50 students cycling through every year. If I had to guess, I would say five-ish might be unpaid. Again, that's just kind of a function of how busy we are, how many projects we have going, and some of the specialized skills we need. So we do have unpaid, but I wouldn't say too many. And a great majority of ours are in fact paid.
Yeah, I would just, I would say that at Cambrian, we don't have any unpaid students. All of the students who work with us in applied research are all paid. We do track capstone projects that we have referred industry partners to. So obviously we don't go into the academic area and count every unpaid student on a capstone project, but when applied research and the Center for Smart Mining has steered an industry partner into doing a capstone at Cambrian, we will go back and track the students' involvement on that project, because again, what we've also tried to do with that is that oftentimes maybe a partner isn't ready to do an applied research project, and the capstone is a good first entry point, and then we build on that in applied research. So outside of unpaid students on capstone projects, yeah, everybody in the Center for Smart Mining and at Cambrian R&D, they're all paid.
And now you guys are making me look bad at making me look like we exploit our students here. But no, honestly, it's a function of they're super keen, right? And I get emails every week about students wanting to help process animals, help lab analysis that we're doing with samples. So I think, so my comments further to that is at Olds College here, we have a co-curricular record that we worked with the register to produce, where so many X hours of experience on applied research, whether it's with our TAC or whether it's with their crops team, whatever, if they reach a minimum, then they get that record on their transcript when they graduate. And a lot of them find interest in that, as well as just getting that experience that will hopefully help in their future jobs.
Yeah, there's all good outcomes that can come from unpaid. Just a little bit of an addition to that, just what you said just kind of struck me. And I thought this might come up as a question, and sorry if I'm stealing someone's question, but we're probably all aware of the, that training to productivity curve. And it's just something to be aware of. And maybe that's a bigger concern if they're unpaid. If they're just keen, but don't really have a direct project to work on, there can be an issue of how long does it take to train someone, and if you're thinking in terms of co-ops, which are 4 months, I think we've all had that experience where you train someone for 3 months and they're gone after 4. So I'm guessing that might be a bit of an issue with unpaid, or a bigger issue perhaps than versus paid, but I could be wrong there.
Well, and that's a good point. Like, by no means do things go faster and are more efficient when you have people kind of even one-offs coming to help. But then flip that around, and it's just the experience and exposure that they're getting out of it, and that we try to foster. Yeah, and we're not putting them in positions of huge responsibility, but even observing to some degree.
Now, traditionally, NSERC, for at least the TAC grant, didn't care much about student involvement. It was more of a metric aligned to IEs and other things. And in addition to a lot of other things, we're seeing that sort of shift. And it looks like they're going to be putting greater emphasis on TACs, engaging students in the activities. That means something has to give, because finite amount of time to do everything else, which is part of your core mandate. Now incorporating the student piece, how much of a challenge is that going to be?
I would say for us, I mean, I think it's, we're a smaller college. And so I think over the years, we've really been trying to, even before the advent of the TAC, is just really try to find different ways to engage more students, because it always comes down to a capacity challenge that, we were maybe 3 years ago, before the TAC was founded, we were exclusively reliant on our faculty members to be released, from their teaching, or to have a modified workload arrangement to bring them into a project, which again, I think is common for some of the smaller, medium-sized colleges. Obviously with the larger colleges, they have, a stable of research scientists or research staff who are able to work on projects. And we've been able to do that through some other funding. And then also now, obviously through the TAC and enhancing our capacities to bring on, core staff researchers who are still able to work with faculty, but have those faculty in a role that I think many of them are more in line with, which is more of an advisory role, which provides that pipeline of students to the projects to then work more closely with the engineers and the technicians, and then having the faculty there as well, but in an advisory and a mentorship role as it ties back to the program outcomes on the academic side. And so I think for us, like, we're eager to embrace that challenge, because I think that we don't do projects without students at Cambrian, because it's something that our president prides himself on. That is a party line that he says to industry partners when he's out in the community. So it's obviously imperative for us to toe that party line. But it's true. And again, I think that it's obviously proportional to the size of the project activities we have at Cambrian. But I think with the model that we've gone towards, with the resources and the capacity that the TAC has helped us build here, it's actually easier for us to bring students on now, because we have the additional supports and capacity that we previously didn't have, 2 to 3 years ago.
Yeah, great. Yeah. And yeah, tax, it's a bit of a burden. I'm not complaining, but training, technical services, helping SMEs and R&D, there's a lot to do. And if your student numbers are up and there's more emphasis on student numbers going up, then yeah, maybe your training is down a bit. So it can be a bit of a juggling act, I guess. If we're just talking about advice today, maybe my advice would be, think of creative ways to hire people and get them working on those other lagging parts, perhaps. We have partnerships with Sarnia Economic Development and a local Sarnia research accelerator. And sometimes we split workers. We might have an outreach assistant working 20% for Lambton and 20% for the city of Sarnia, and all sorts of things. And you can do that splitting internally. Is there anyone within the internal college in the marketing or communications department that gets seconded or split their time? Paying from those can be from the grants too. There are often outreach. You can have a small budget item or not so small for outreach activities and developing training courses, all those sorts of things. So we try and bake that into a proposal, and then we look for, creative solutions internally or externally with other partners.
That's an interesting point. I know a lot of the focus has been on students participating technical roles, directly linked to the project, technician, technologist, skilled trades, all the stuff. What about some of the periphery skills that you need in the research office? Maybe it's project management or comms or media. Have you gone down that road yet to tap into those faculties, those schools, to give people opportunities to get some hours toward their PMP designation or something like that?
Mike, were you shaking your head at that?
Yeah, sure. So Ken, we have done that before, and it has worked out quite well. We have students in the business program here who obviously have project management as part of their studies. And we've had students not lead projects, but they've managed the projects with an applied research developer and the faculty member or the research staff. And so it's a great way for them to get hands-on project management experience with a real project at Cambrian under with the supports of the staff and the team down here. So that's definitely something that we've done, and we still continue to do now. We've also found that outside of that group, not so much communication, but graphic design has been, I think, a boon to us as well. Oftentimes when we're doing prototype development projects, you arrive at a product at the end, right? And now it's time for the industry partner to commercialize that. But like, what is that product called? What does it look like? How could the marketing collateral look? And so even though sometimes the partner doesn't necessarily say, I would like you to build this prototype for me and also provide a brand for it, that's something that graphic design students and even marketing students do a great job at, so that when you leave here, you have your MVP, but you now also have an idea as to how I could roll this out when I go to a trade show. And and so we've done that. And certainly I think there's definitely a lot of synergies there with those programs, where oftentimes we know from a technical perspective, we're going to need, an electrical engineering technologist student on this project, and we'll need a welding and fabrication student. But, the output of this project might also require somebody with a comms a marketing background or a graphic design background. So I think that's another thing too, is sometimes even if the partner is not asking for it, there are ways that you could leverage some complementary programs at the college that still could add value without obviously necessarily, kneecapping the budget, so to speak.
and obviously wanting to avoid correlation causation, but something Dr. Robert Luke and I were discussing a little while ago was the labor market outcomes for the students who participate in applied research projects at a TAC, a college, whatever, and tracking that, because once they're out the door, the hooks they have into them aren't as deep. So we're kicking around the idea of either a digital badge or a micro credential that people could put on their LinkedIn to say they participate in an applied research project, but it's, I guess, not blockchain. Again, I don't understand much about technology, but that it's validated or endorsed by the TAC or college research office that hosted them for the project to show that it's legit and valid. And that way it allows a little bit of tracking on the TAC side to see where did these people go 2, 3, 5, 6 years after they were hands-on on a project. Where are they now, kind of thing. Does that resonate? Would that have a utility, you think? Or is it already happening?
I think so. I think it does resonate. That is happening at Lambton. We have an innovation institute that's working on badges and micro credentials, and that got accelerated with COVID, but that's a great idea. And Ken, you really, tickled my brain a bit there with how to track these people with those badges. I guess those are little electronic tracking devices in a while, because we always run up against that issue of, what happened to those students? We often know when it's a month or, a year maybe after graduation, but longer than that, what happens to them. So yeah, I think it's great for the students. I think it's great for our own metrics as well.
Yeah, we've been tracking that, and obviously there is challenges with, they change their emails or they relocate, but we do have, through the work that our administrative assistant does in the office, she reaches out to those students at 6-month, 12-month, increments like that to find out where are they now. It's funny that you mentioned that, because I think we've done a better job at trying to manually track that over the last couple of years. But we did a tour in applied research, and one of the partners that we had there, one of our students had worked on an animation project with them. And through the course of this tour where they were showcasing some of their technology, they mentioned, that one of the students they worked with, ended up working on a project with Disney. And that was something that we didn't know about. And at that time we said, okay, we need to follow up with Veronique, because clearly there's a great story there that, she was an animation student at Cambrian, worked on this applied research project, is doing some work for Disney, the extent of which we don't know. But again, it's great when you kind of get those stories from your partners to say, I should follow up on somebody like that. But I think we've been trying to come up with a way to manually track, but certainly I would welcome, another way of displaying those badges. Obviously we want to kind of keep tabs on where they go, and highlighting the experience that they've had in applied research to entice other students to join up and see what the results could be.
Because I love the idea of having ambassadors for college applied research out in industry, trying to convince their company, hey, let's go work with ATAC before we build our own in-house R&D capacity. And it's obviously tough. I mean, in a previous career, one of my files is labor market information. So I'm kind of passionate about that, and how deplorable Canadian labor market information is compared to Europeans, just the outcomes of, college grads versus university, blah, blah, blah. My hypothesis would be that the students who participate in applied research projects tend to outperform their peers, either in the same program cohort or even, a similar cohort at maybe another institution, just because of that competitive advantage they get. And it'd be really neat to be able to see what they do with it. But again, correlation, causation, that kind of fun stuff. I guess mindful of time, as the next sessions, well, it's the ARTP matchmaking session, which ironically is in this room in a few minutes. So just wondering if anybody had any final thoughts, comments, help needed, future directions. We're all ears. Well, then I guess I'll turn it over to our co-hosts for their final thoughts and pearls of wisdom before we do a little pivot.
Thanks. Sounds great. I did see a comment come up about LinkedIn being a great way to track people after they're gone, and that's a great tool. I agree with that. Final pearls of wisdom. I think I'd say, what's worked well for us is, giving that student, they're a student, they're young, potentially young, and maybe not, but even if they're not young, this might be a new area for them. They're being trained. and to really give that student, some autonomy, some skin in the game, give them some responsibilities. It's a bit of work to try and gauge how much responsibility they can handle, and that's a two-way street with feedback going back and forth. But in general, let them take ownership of a project, give them objectives, explain the big picture to them, and then if possible, give them the freedom to say, okay, here's the end goal, here's the big picture. We need to get there in a few steps. What do you think? And what are those steps? And can you handle it and run with it? And that's worked out really well for us. The students really respond. It's great for them, great for the company, great for research and innovation department. And then one other little tidbit of advice I heard earlier about the ups and downs, the peaks and valleys of being busy. In downtime, when we have many students in the lab, we often, if their project is in a bit of a lull, we'll have them shadow other people. And, maybe that is not their project that they have autonomy on and objectives to do, but they can now shadow someone and learn a new skill in ICP or GC or all these other fine tools we have. So just like to leave it with that. Let the students run with it and keep them busy. Thanks so much.
Yeah, I guess I would just say, just to kind of echo some of Rob's comments, that I think, for us, I think one of the learning curves we had with onboarding those students full-time hours over the last summer was just, I think, being able to adjust and adapt with them to make sure that they have the proper supports necessary to be the drivers of those projects and those activities, right? I think it's easy enough to say that we're going to empower them and put them into position to do that. But our team had to realize, quickly, not only from a supervisory perspective, but also just making sure they have what they need. They have clear guidance and direction on what they're doing. They have the proper supports in place when it comes to equipment operation and all those sorts of things. And so I think our team, recognize obviously the benefits of what these two students could bring to our team, having them on our roster for the summer. But I think also recognizing that if you really want them to succeed and put them in a position to succeed, you have to provide the commensurate resources from the tax side so that they are well supported, so they can actually go to that level that you expect them to do. So I think, again, that's not, I think we all recognize that, but I think it's important that that's a big part of putting them in positions to succeed, is being there to support and drive those activities with them. So again, thank you. Appreciate it.
That's fantastic. Thank you both. I think it's just real quick, because again, I have editorial discretion. That just tweaks something for me. A lot of these programs that support students or graduates to do internships, it's 18 to 30. Is 30 years old a rational cutoff anymore, given the average age of the students on a college campus kind of thing? Or should that be bumped up to, it's an antiquated number. It's been that way for 40 years. Is it realistic anymore?
In our experience at Cambrian, no, for sure. And I think I'm sure my colleagues could echo that. But again, I just think of an example. We had a student in welding and fabrication 2 years ago before the pandemic. She was an engineer and she went back to school to get the hands-on experience as well. So again, she would have been outside of that age bracket. And again, I think you're right. I think we're seeing more and more of that, Ken, where people are coming to colleges after getting a degree, or they're starting a second career and they're going to college for the first time. So I think, viewing it from that lens, obviously you could kind of limit yourself to, I think, a great talent pool, that you can leverage those additional skills that they would bring to a project.
And I just say maybe 30 is a bit arbitrary. What that number is, I'm not sure. Maybe no number, right? A student is a student, but I'll just leave it at that. That's a bit of a tricky question.
Yeah, because I mean the range is 18 to 30 for post-secondary graduates. I don't know too many post-secondary graduates at 18.
Mm-hmm.
So it's silly. So that's another thing we're just trying to get raised to be just realistic to 2021.
Mm-hmm. Good point.
Okay, well, again, yeah, thank you, gentlemen, both so much. That was an excellent presentation. And I guess we'll just do sort of a magic screen wipe and boom, oh, now we're in the breakout session for the ARTP matchmaking.
Thanks so much.
Thank you. So I believe some of the other sessions are still going on, so we'll just sort of hang out here for a bit.
I just joined from room 4 and they're getting finished. So
okay, good. I'm not sure how much uptake or traffic we'll get for this, but wanted to give people a chance to raise their hand, turn on their camera, make their pitch, and then everybody else can go find them at the coffee break after, in theory.
Well, actually, the topic of a conversation on room 4 was the obstacles to collaborating between TACs. So I hope these guys will come in.
Scared them away. Hey, Terry, how we doing?
I say, well, actually, I popped my email up for just a half a second because that was the temptation to see that long list. And then I closed it right away. I thought I should just have more fun here.
We had a really good session with David and Peter.
Thank you so much.
Very interesting.
Excellent.
Richard, Melanie.
That's why we're late.
Well, thank you, Chantal.
That's good. And
We have some homeworks for you, Ken.
I don't know.
uh-oh.
So I guess you can charge us to deliver those services then.
Sounds like a plan. Seems like we've been picking up new homework all day, so that's good. They'll keep us busy.
So Ken, the evaluation of the RTPs was yesterday and today.
Mhm.
Do you have the results for us?
Not- not
You're
at
well
4
connected,
o'clock.
aren't you?
Oh yeah, and then I'll get it because the thing I'm most interested in is the split of how many were option 1 versus option 2, and the value asked for from the sector, predominantly for the stream 2 ones. Like, did they only
Yeah.
get 20 proposals? And even if then was the value requested 6 million or 60 million? Because depending on how many get funded, that arms us with an angle to go to ISED and talk about maybe a SIF stream 5 or something, since they're plug and play, ready to go projects. But alas, I will put the word on the street and see what we come up with.
Interesting to see if anybody Ensrick has any hair left. There had to have been a whole lot of wailing and gnashing as he went through this whole process.
That's true. I know Jack was running on empty already, so there's probably not much left. Maybe Homer Simpson's 3 strands. That's it. All right. Is the other session done?
Yeah.
Okay. Well, the more people joining us, this is really just an informal session related to I guess the second round of ARTP for everybody who has applications due December 15th. If anybody's still looking for dance partners, here's an opportunity to just put up your hand, turn on your camera, maybe give a 30, 45-second explanation of what you need to round out your team. And then the participant list is on the website, so they can be in touch with you shortly thereafter, and collaboration can begin. So is anybody in need of a partner or want to go first?
Well, in front of all these people rushing to say something, I guess I will seize the occasion, rise to the plate. We are looking at doing a biorefining Pratt. That's the name in French, ARTP in English. We have 2 other colleges already, but if there is an interest within the tax for joining this endeavor that we're actually starting to talk about with Innofibre, I see Jean-Philippe Jacques right here. He's already with us on this. And there's also CNET, which is, but we're looking at scale-up technologies for biorefining. So if you have big vessels or big infrastructure that can participate to biorefining, and I'm talking scaled up processes, big stock. I'm interested into knowing about what you're doing and what you you could contribute to such a program. We don't have partners out of Quebec yet, so that's certainly something that we could be interested in seeing if anyone wants to join us on this proposal.
Fantastic. Thank you very much. I don't see Rob Nickel on the line, but we'll relay that to him at the Bioindustrial Process Center down Lambton Way. They might have that bench strength as well. Oh, I see Rob.
I was trying to be sneaky and just listen. That sounds interesting. Maybe we'll talk offline. I'm not sure if we have the size you need, but that's definitely of interest to us in our wheelhouse. If we don't have the size, we are talking about next steps and how big do we get. But yeah, we could chat some more.
So you have projects in biorefinery, biorefining.
Yeah, we have a lot of good partners from biomass producers. So it could be agri-food waste or it could be purpose grown biomass. We have great connections to both those groups. We have projects right now with both those groups. Then the processing of that biomass and then turning it into, either bioconversion or thermal or other conversions into finished products. Our scale, though, it might not be big enough. It's, 50 liters maybe is a big reactor for us. 100 liters is the biggest we have, 50 to 100.
Okay.
But yeah, if that fits, or if there's other things, maybe we're a small support in terms of chemical analysis and quality control of what you're trying to do. That could be a fit as well.
Okay, so I'll reach out.
Sounds great. Thank you.
Excellent. Thank you. Anybody else looking for a dance partner?
We're good for now. We submitted 4, well, actually we were partners with 4 ARTPs stream 2. So we'll see what happens with that. So I guess we have enough on the go for now. Yes, we'll wait.
Great. Terry, how about you? How you doing?
I have my lot full, but I'm always interested to see what else is possibly out there. So I'm just one of these passive people sitting around looking to see what's happening.
And I guess it might depend on the results of the ARTP round 1 about our capacity and how much more we can do. So general at Lambton, we're very interested in always getting new partnerships, always new projects. But yeah, I guess we'll have to see how it goes in round 1 to decide how many we put in for round 2, because there were no limitations in round 1 either, right? And I suppose it'll be the same for round 2 as well.
Yeah, my understanding is they received 90 proposals for stream 1 and 2, which very much surprised them. So, and we know of a number of people who are holding off intentionally to submit in round or the second competition. So I mean, they're being adjudicated today or yesterday and today. So people will probably know within a week or 2 whether it's yay or nay, and that should give people enough time to resubmit for the 15th if they'd like. What we don't know is whether feedback will be provided to you by that time to address what the shortcomings might be. Again, still TBD. No idea on the award count, because they've got 47 million over 2 years, and it's all got to get out the door in these 2 competitions, but we're not sure what that breakdown is. Andrea in the chat, we're putting one together for December and water treatment related to industrial water. Sate and Cod are working with my team. Fantastic. Great partners. Well, yeah, I was going to open a Pandora's box and say, if there's no specific project pitches, maybe we could talk about what worked and what didn't with that program, but there's probably not enough time for that in the rest of 2021.
yeah, I'm kind of wondering how they will determine if they give full funding or half funding or quarter funding or whatever funding, and what we are supposed to react if we get X funding with a program that we've described for full size, and then we have to downgrade. But we'll find solutions. If they bring money, there's always solutions, but still, I'm wondering.
Yeah, that'll be interesting to see because I think they want to fund 90 stream ones between the two competitions. So 90 colleges, CEGEPs will get that stream one award, and then whatever's left over will be divvied out for the stream two collaborative proposals. Really don't think they were expecting that much collaboration interest from the community. So we'll have to see.
We're just a collaborative bunch, that's all.
Well, we've never been allowed to before, so it's great. I mean, you know, CUI2I Innovation Links, whatever it was called, that failed precisely because it was mandatory to have a university, a college, and industry partner at the table. You know, we've never been taught how to collaborate with universities for industry, let alone collaborate between colleges to serve industry. So it was an idea that was way too far ahead of its time. And I mean, if this stream 2 of ARTP works and the community likes it, there's no reason why we can't go get more money for it and make it a permanent fixture. Just like Coco SIF is a permanent thing now because it works.
I actually see this working across Canada very well. It's just a matter of it's never been done before. So, and the frustration is, as we all mentioned, how much do we have? We don't know. And so that's one of those interesting factors where if you design something, you design it to work. So ideally you fund it the way it should work.
Yeah, I'm assuming the projects you put forward weren't really scalable or modular, where you can take components off and swap them in depending how much money you get. That doesn't seem right. Well, I guess if no other pitches or requests or anything, we could wrap this session. And for anybody who'd like to, slide over to room 5 for just the hangout informal networking chat. Then otherwise, we'll see everybody tomorrow morning for the annual meeting. All right. Thanks, everybody.
Thanks, Ken. Thanks, everybody. Hello, Wes.
Hey, Jean-Philippe, how are you?
Good, and you?
Good, thank you. So I'll just give you some context. We have some faculty here that have written a research paper on the benefits of biochar.
Okay.
For the beverage sector specifically, the economic viability. The researchers are in the business school. The paper they've written shows that it's economically viable to produce biochar from wine pomace, the spent grape material from production of wine, and use it for things like remediation of soils to improve soil health, which is a big problem here in the Okanagan Valley where I live. It's desert-like conditions. It's pretty dry.
Okay.
So they have been inquiring with us about the estimated amount of biomass in the valley here. And for the wineries, it's in the thousands of tons of wine pomace. For the breweries and distilleries, it's tough to calculate because they don't measure all the spent grain from making beer or spirits. But when I spoke to one of the the largest producer in the province, they estimated they do about 8,000 ton of spent grain a year.
Okay.
So we're getting into
And
good.
excuse me, is it on a dry weight or as is?
It is, I'm guessing it would probably be 60 to 70% moisture, water
Okay.
content, because it comes out of the mash tun
Okay.
wet, still soaked with water. So I'm
Okay.
guessing the bulk of the weight is still water weight. So take the 8,000 tons and I don't know, maybe take 2/3 of it off.
Okay.
So they've been asking about us being the BTAC trying to find a way to do a small scale amount of pyrolysis to biochar so that we can look at the end product. You know, what does it look like, and is it actually suitable for soil remediation here in the valley?
Okay.
And you know, for us to go out and buy a pyrolysis machine and a dryer and set all that up, it far exceeds our funding. You know, it's the stuff you're working with is not cheap equipment. At least the stuff that they priced to us. So I was just curious if you had experience with spent grain or pumice, and if so, how efficient was it compared to other materials for pyrolysis and that sort of thing. So sorry if I'm a little out of lockstep with what you guys do exactly, but I
That's
wanted
okay.
to ask.
Not a problem. So, well, basically, we never do a pyrolyze this kind of feedstock, but we use different kind of feedstock. For example, we do some pyrolyze on residues of cannabis, for example. So it's something on what we are working. The first thing, you have a high moisture content. So
Yeah.
we have to look if how we can dewater the feedstock. So I'm thinking if there's some mechanical process, we have a screw press here, we have another different kind of mechanical technology that we can use, but at the rate of moisture content, we will not remove a lot of water. So we have to think about probably a dryer. So for that, it's not an issue. We have a pilot dryer in our pilot plant. Also, your feedstock, can you give me an overview of what is the particular size of the feedstock?
What is the which?
The particular size, is it like a sand, or it's something? It's a bigger particle.
It's for spent grain. It's like oatmeal porridge. It's just barley and malt grains, wet grain. So it's in a soft, mushy form.
Okay, I understand. We did some work on the microbrewery grain, for example. So
okay,
it's something like this, I suppose.
Yeah, exactly.
Yeah. Okay, good. And I'm gonna share you. I can share my screen. Is it a corporate presentation? Right. Okay. Can you see my screen?
Yeah.
Okay. So is there? Okay. So I'm gonna show you equipment. Okay. So you see here the equipment here, the gray one.
Yeah.
It's a dryer. It's a bed dryer. So we have the capacity to dry. It's 2 tons per hour that we can dry. So it's something that we can do before to do the pyrolysis system. And I'm just looking for the technology. Okay, not in this presentation.
Okay.
I'm gonna use another one. No, not here. This one. Okay. This one's good. Okay. So, do you see my screen? Is it the good
Yeah.
one? You see the presentation? Yes.
Yeah.
Okay. So here is the dryer that I told you. So is it our pilot dryer? And we have here is one technology. It's a slow pyrolyzer system. So with this kind of technology, sorry, the feedstock have to have a moisture content of 30% roughly. And
Okay.
usually we use the feedstock, the particular side of the feedstock, it's sawdust. So
Right.
give
Okay.
you an idea. And this one is another technology. So it's for, I would say, for reactor. In the middle, we have a common burner. So our the syngas is going at the burner in the middle. But in this kind of technology, we can look to fill with your feedstock, but we have to do some setup inside of the oven if you want, because we at the end we're gonna probably make a pane, or not a pane, but a braid. So it's I'm not sure that our the feedstock in the middle of the bucket will be heated and we'll get some biochar. So
Okay.
we have to do some modification inside, but it's something that we can look. So this is it's pilot equipment, but of course we have some lab equipment that we can use some gram to see what can happen.
Okay. Let me have a chat with them and see if they can find a source of funding, maybe we could work with one of the local distilleries. Where in Quebec are you?
Yes, in Quebec, in Three Rivers.
Okay. We could find a local brewery or distillery maybe to partner with through the college here and get money your way so that they could advance their thinking around the suitability for spent grain and pumice.
Yes. But maybe at first, can you just send me a sample of the feedstock, a bucket, for example? Ship
Yeah,
me
I can.
this,
I can grab it.
if you can, just a small sample, just to see that we're gonna take some analysis like the moisture content and the particle size also. So it would be helpful for us to know how we can produce biochar with this feedstock.
Yeah, I'm happy to do that, and it may not be possible, just given how much moisture there is. It may not be worth it, but the spent grain and the pumice mostly ends up in either landfill or in the cattle and hog industry, feeding pigs and cows. So there's other purposes for it, but none of them are really sustainable long term. Gives off a lot of CO2.
Mm-hmm.
So, but yeah, let me see if I can grab some stuff and send it your way.
Yes, it could be useful for us. And for your information, we do some paralyze of residues of vegetables. So it was reduce residues, for example, that we do.
Yeah.
We did some biochar with it. So the project was to use this waste and to use it as a soy amendment for different farmers. So that was the project. And maybe sometime what we try to do, we're gonna mix two kind of feedstock. So sometimes it's come a technology because when we want to dry, it's something very expensive. So
yeah,
we can mix two kind of feedstock, but we will not necessarily have an homogeneous biochar at the end, but we can produce something that could be interesting it depends of the utilization at the end.
No, that sounds great. All right. Let me chat with the researchers and I'll reach out to a couple of companies here and see if I can get some small package your way so you can see what we're working with.
Yes, please. And
Okay.
like I said, a bucket, 10 liters or 20 liters, it will be fine. So
Okay.
we'll do
And do you want some of the finished products sent to you too? The whiskey or the wine?
but if you want, no problem with that. We're gonna try. We're gonna see the moisture content and
Are you a wine drinker or a spirits drinker?
more spirit drinker. I prefer more Scotch, bourbon, and
Okay.
this kind of.
Well, we'll see if we can get you a bottle of bourbon from one of the distilleries and send it your way.
And also, no, I appreciate also the microbrewery. There's someone in Quebec, and I was a part of. I was a partner in a microbrewery a couple of years ago, 10 years ago. So
Oh, which
Yes.
one?
it was L'Hermite at Victoriaville in Quebec.
Okay. Yeah, yeah.
So I was a partner. It was my friend. We did a master and PhD together, and then they stopped. My colleague Mark and William, they stopped to the research, and they was full time on the microbrewery. So
Huh.
no,
Okay.
it was a good thing. It was very funny, and now we see also in Quebec there's a lot of micro distilleries. So in True River, there is one or two. So
Yeah, there's more and more all the time, and some of them are getting pretty good with their spirits. Especially, we've had some products come through here that are surprisingly good, surprisingly well distilled spirits that hold up against. I don't know what bourbons you like, but certainly if I'm drinking an Angel's Envy or Michter's or some of these bigger Kentucky-based brands, some of the local small distilleries here have products that are close to that quality, like just really nice full-bodied bourbon. So yeah, they're getting better.
I think I have to do a travel to visit your lab.
I told Ken that we'll host the TAC conference one year out here. There's enough wineries and distilleries here to keep everyone entertained for a while.
That's
So-
funny. And I'm just thinking in True River they start a lab. It's like a food lab. I don't have the good term, but maybe it could be interesting for you to know a little bit more about the project. And if you want, I can put you in contact with the manager at the city who developed this lab.
That'd be great. I'd love to see where and how we can help them, in any way. So, we have, it was interesting sitting through your presentations because, we have one of those challenges where we have a small team, we've got a good chem lab, a good micro lab, sensory, and a bunch of other equipment for support. We do a lot of product innovation, but this year I'll probably do 20 or 25 interactive visits. So, and part of our challenge is, I liked your talk because part of our challenge is making sure we can move some of them further up that sales cycle to bigger and bigger funding opportunities and revenue opportunities for the TAC. And it's hard because we deal with a lot of small business and beverage manufacturing.
Yeah, I agree with you. When you start, you have to develop your collaboration. You have to develop your name and to be recognized from industrial partners. So I understand it's not really easy. And so interactive visit, it's like I said, it's a good program, but my experience it's that the customer for interactive visit, it's SME or startup. So when you're talking to say, hey guy, we're gonna do another step, then say, okay, oh, not sure, we're gonna wait. So it's fast, it's relatively easy, but just the time you put to manage a project is the same time that you put to manage an engaged project. You have to do a kickoff meeting,
Yeah.
you have to do a midterm meeting to present the result, you have to do a report and to close the project. So, you know, if you consider all the time you put just to manage a project, and in 20 hours, you're gonna grab maybe the quarter of the 20 hours just for the managing.
Yeah. Yeah, you're absolutely right. There are a lot of work other than the fact that, you know, we're still trying to get our foundation here in place. We're only a year or two old. We launched right into the pandemic. So, was an awkward time to launch, but yeah, we've been trying to figure out the best way to scale certain things. There's a lot of money in the Valley. I mean, a lot of the wineries here in the Valley are the bigger ones. The fellows that started them up are worth anywhere from 500 million to 4 billion. So the money's here. It's a matter of tapping into the right opportunity with those companies.
And does the company are interesting to do innovation, to develop new product, new process?
Yeah. If I take example, there's a company, a parent company out here called Mark Anthony Group. Their original innovation in the beverage space was Mike's Hard Lemonade, which I don't know if it was much of a seller in Quebec, but it was an alcoholic lemonade that sold for years and years. They sold it to, I think they sold it to Molson or Labatt's a couple of years ago for about 400 million.
Okay.
And they rolled that money into their new product, which is White Claw. And White Claw is what's called an RTD. It's a combination of carbonated water and pure alcohol, like neutral grain spirit. And it's just flavored. The cost on it is about 18 cents, I think they quoted, to produce it.
Yeah.
18 cents a can, and they make, I don't know, they make a ridiculous markup on it per unit. So I think the founder of the company, Mark Anthony Group, his personal wealth is just over 4 billion. I think the group itself is worth probably 5 times that. But they do nothing but innovation, and we're trying to tap into pieces of that innovation cycle that they do. So it's just a matter of getting to the right people within their corporation to let them see the value of what we do versus the costs related to their own research internally.
Sometimes it's not as hard, but well, the big company, the large company, it's interesting, but sometimes it's hard to do business with them. So, for example, they have the choice the big company have the choice to work with our lab all around the world. So
yeah.
And in comparison, SME, it's local. They like to be in contact. The budget is lower, but we can do good project with them. So it's I understand your situation, and so Fiber, we are in the industry since 1989. So we are a good background, 30 years of background, but it was not always easy. We have some things. In the past, we had a big project with a company, and we have roughly 8 persons who was involved, who was working for this project. And one day the company said, okay, the company is sell, so we stop everything now. So we have to say 8%, sorry guys, I can't keep everybody. So we have to just turn and to see what's gonna happen. So this is why I said it is good to have a big project with big company, but SME, it's really important also to have this kind of company in your portfolio.
Yeah, we're mostly small and medium enterprise right now. It's but the amount of innovation in the space is hard to keep up with. So it's good. It's a good problem because I like the end product. I like drinking the end product.
Yeah.
So
And tell me, do you know if your customer have an interest on the recyclable bottle?
well, the answer right now is absolutely, because the supply chain for bottles, glassware, cans is so long for these guys
Okay.
that some of them are not packaging. Like they're moving products into draft, like breweries are moving it into keg because they can't get the cans on time. There's a high demand for like 250 ml recycled aluminum cans. There's a high, I had a distillery call me the other day looking for glass bottles because the supply chain's too long. He wanted to know if we knew anyone. Same thing with plastics and pretty much everything else. If there's a container they can put something into that is stable, they're looking at all their options right now, because trying to get a container out of China or wherever the products are usually made onto the west coast of Canada right now is, in some cases, it's gone from weeks to months for delivery. So yeah, there's definitely interest in it.
And is it due to the pandemic COVID-19, or it was like this before?
It was, so it was growing, it's been growing over time, and it's been shifting over time. So there was a shift from glass to aluminum because of the weight associated with glass relative to aluminum. So the cost of shipping and the CO2 footprint for many wineries and breweries and distilleries were moving them out of glass into can. There was a shift with wineries to move some of their wine, usually their cheap wines, into aluminum, so that it's more portable for Gen Z, like the younger consumers who don't want to buy a big bottle for 30 bucks. They want to buy an aluminum can of the same wine for $4.50, and drink that at the beach, or, drink it when they're hiking or camping or whatever they're doing. So it was moving back and forth quite a bit for glass and can and plastic. And now a lot of people are just, I'll take what I can get because of the supply chain issues. So yeah, I would say there's probably an interest if you have access to supply.
Well, not now, not really, because I don't know if you saw Carlsberg and Johnny Walker. They do they launch a recyclable bottle. So it was a bottle in paper, and they say that it's something that we can recycle. And currently at Innofiber, we are working on different. Let's see. Ouch! Is it some? For example, is this kind of cup? It's made from cellulosic fiber. So, for example, and we are looking for a process to develop bottle presently.
What would be the lifespan of that on shelf? How long could I stick a beer or a spirit or a wine into that vessel and expect it to last?
For that, the same, where we're gonna put inside a coater. So it's coater for water and drink. So you can see it's a single use, of course, but you can keep the beer or the wine inside a couple hours with no problem.
Okay.
Or the other, I will just come back.
Sure.
Another possibility. So presently we can do that. So it's a bottle in two pieces.
Yeah.
So imagine that you can, we can put a glue here to stick, and inside we can have a small layer of plastic. So
yeah,
if you compare to a bottle made 100% of plastic, the quantity of plastic, the layer inside would be lower.
So if I look at that container, I'm trying to think through practically how I would fill it and how I would seal the end if it was going to go on shelf.
But you know, this kind of bottle, it's a big one, but this kind of bottle, we saw about this kind of technology. We saw this at the liquor store here in Three Rivers.
Oh, really?
So it was
Okay.
a market for that, but now there are no one on the market. But we have a sample here of this kind of bottle, but it's something that the problem was here because you know when you just in the transport and the manipulation, sometimes the glue is not enough and it's gonna split like this, and the plastic layer gonna have a hole, and well, you lose the wine. But it was some issue that the customer have, but the technology already exists, and what we are looking for presently it to produce a bottle and paper, but in one mold. So it will be one part, and we will do the extrusion of the bottle. So
Okay.
this is something that on what we are looking for, but the technology is not there probably in maybe 3 or 5 years. But I'm just curious to know if the customer is looking for something sustainable packaging in this industry.
So for sustainable packaging, if it's lightweight, if it's recyclable, if it can hold up to either a low acid environment, because not really low, but a lot of the beverages are in the 3 to 4.5 range for pH. Would be helpful to know if it stands up to carbonated versus just still beverages. And then the only other thing is the opportunity for branding. What does it look like on shelf, or would they just sell these out of their own winery or distillery, for example? But there's absolutely an appetite for it. We've had companies approach us about for the 6 packs of beer. There's a company called PackTech that puts on a plastic applicator to hold them. You would know them from your previous life. So we're looking for new applications that use that PackTech equipment, but will allow us to use products like yours to adhere that still have the.
Something, well, I think I have a sample here. Where is it? Well, I understand what you're talking about. So that's something that we can. Well, it's something that we can look to develop.
Yeah, it's the cost of distribution around Canada is not insignificant as a component of their distribution economics overall. So anything that provides a better packaging format that is more compact, especially if it's user ready and recyclable or biodegradable somehow. There's more and more providers that are willing to look at it. And if it's a homegrown Canadian-made product, even better. Okay. A lot of companies are trying to repatriate stuff from offshore. The supply chain issues now have just proven that they can't go to, China and India and Malaysia to source all their products, because now they can't get stuff packaged on time. Okay. So yeah, I'd be quite happy to take a look at some of your products for suitability here. There's probably no end of applications if we can find the right partners willing to try it.
Yeah, no, that's interesting.
Yeah. So,
Good.
all right, well, I'll let you go. It must be near the end of your day there. So,
It's the end of the day never happened here.
no, it doesn't here either. So, but I'll see if I can grab some samples of that stuff for you and ship it over with a bottle of local bourbon. You guys can,
Yes.
even if you can't use the product in biochar making, at least you can have a drink while you're looking at it.
Yeah. Good.
So-
But can you just maybe write me your email in the chat?
Sure, one second.
I will send you my contact with the address for shipping.
Okay,
And do you have like a one pager of your tag or
I can send one across.
something like that? Because I would like to share it to the manager at the food lab here in Three Rivers. So maybe there's something could be interesting for you. I don't know.
The website probably has
Okay.
the best one pager on the front, just on sort of what we do.
Perfect.
But yeah, yeah, shoot me a note. I'd be happy to chat further about it.
Good. So I'm gonna contact Etienne, the manager, and if it's something interesting, I'm gonna put you in contact with him.
Okay, sounds good. Thank you so much for your time.
Thank you.
All right.
Take care.
Talk soon.
Bye.
Bye-bye.